Getting an SSL certificate is step 1. Verifying that it's working correctly end-to-end is step 2, and it's just as important. A certificate can be installed but misconfigured in several ways. The wrong certificate file, cert.pem instead of fullchain.pem, causes mobile failures. The certificate for a different domain causes common name errors. An incomplete certificate chain shows the lock icon on Chrome but fails on Firefox or older Android browsers. Expired certificates are silent failures if no monitoring is in place. And beyond the certificate itself, the HTTPS stack involves multiple layers that can each fail: the certificate, the Nginx SSL configuration, the proxy_pass to node.js receiving the correct headers, the HTTP to HTTPS redirect behavior, and the application's session security settings. A thorough HTTPS verification catches all of these issues before users do. The 5 minutes you spend verifying after setup saves hours of debugging later and prevents embarrassing security issues in production. This chapter gives you a complete HTTPS health check, a set of commands and tools you run after any SSL configuration change to confirm everything works correctly end-to-end. By the end, you'll have a verification checklist you can run in under 10 minutes and be confident your HTTPS setup is correct. curl is your first tool for verifying HTTPS. Several curl flags reveal different aspects of your SSL configuration. Test basic HTTPS response, curl I https://myap.com. The I flag requests only headers. You should see http://2200 OK, or 200 if http://1.1 at the top, followed by response headers. If you see a certificate error, curl outputs an error message before the headers. Test certificate verification explicitly, curl verbose https://myap.com 2-in-1 head -50. Verbose output shows the TLS handshake details, which TLS version was negotiated, which cipher suite, the certificate CNN expiry, and the certificate verification result. Look for SSL certificate verify OK. This confirms the certificate is valid and trusted. Test HTTP redirect, curl I http://myap.com, plain HTTP. You should get http://1.1301 moved permanently with a location, https://myap.com header. This confirms your HTTP to HTTPS redirect is working. If you get a 200 on HTTP, the redirect isn't configured. Test the redirect chain, curl li http://myap.com. The L flag follows redirects. You should see the 301 redirect response followed by the final HTTPS 200 response. This tests both the redirect and the HTTPS response in one command. Test from a specific IP, bypassing DNS curl h host, myap.com https://165.22.58.101. The host header tells the server which virtual host you're requesting. This is useful when testing before DNS is set up. You can test by IP with the correct host name. Test response time, curl o/dev/null/sw%, time_connect, %, time_app connect, %, time_total, https://myap.com. This shows the connection time, TLS handshake time, and total time in seconds. Beyond verifying that HTTPS works, you should verify the certificate details, the domain coverage, expiry date, and certificate chain. Using openssl to inspect the certificate, openssl_client connect myap.com, 443 server name myap.com. The server name flag enables SNI, server name indication, essential if you're using the same IP for multiple HTTPS sites. Without SNI, you might get the wrong certificate from a multi-site Nginx setup. The openssl_client output shows the certificate chain, your cert, intermediate CA, root CA, the certificate subject, CN equals myap.com, the subject alternative names, which domains this cert covers, validity period, not before and not after, the cipher suite negotiated, the TLS protocol version, verification result, verify return code, 0, OK, means all checks passed. Checking expiry date, openssl_client connect myap.com, 443 server name myap.com 2/dev/null openssl x509 not dates. This extracts just the validity dates. You should see your certificate's expiry date. Verify it matches what certbot shows. Checking which domains the certificate covers, openssl_client connect myap.com 443 server name myap.com 2/dev/null openssl x509 now text, grep2 subject alternative name. This shows all domains in the SAN extension. Verify myap.com and www.myap.com are both listed. Checking the issuer, openssl_client connect myap.com 443 server name myap.com 2/dev/null openssl x509 not issuer. For Let's Encrypt certificates, you should see O equals Let's Encrypt. Qualys SSL Labs provides the most comprehensive public SSL configuration analysis available. It tests dozens of aspects of your HTTPS setup and gives you a letter grade from A+ to F. To test your site, go to sslabs.com/SSL test and enter your domain. The test takes 1 to 2 minutes and checks TLS protocol support, TLS 1.0, 1.1, 1.2, 1.3, cipher suite security, certificate validity and chain, forward secrecy support, HSTS configuration, vulnerability checks, heartbleed, poodle, beast, crime, robot, and many more. Score levels: A+, HSTS enabled, only TLS 1.2/1.3, strong cipher suites. A, good configuration. No HSTS or minor deductions. B, some deprecated features enabled, TLS 1.0/1.1 support, weak ciphers. C or below, serious issues that should be fixed. F, severe problems like vulnerable cipher suites or certificate chain issues. With Let's Encrypt and certbot's default Nginx configuration, options SSL Nginx.conf, you typically get an A rating. To get A+, add the HSTS header. What to look for in the report: certificate section, verify the chain is complete, the domains match, and the expiry date is correct. Configuration section, verify session resumption shows supported, improves performance, forward secrecy shows supported, important security property, and there are no known vulnerabilities. Protocol support, TLS 1.3 should be enabled, TLS 1.0 and 1.1 should not be enabled. The SSL Labs score is a good proxy for, is my HTTPS configured correctly? Run it after any SSL configuration change. HTTPS verification doesn't stop at the certificate and Nginx. Your Node.js application also needs to handle HTTPS correctly. The X-forwarded proto header, because Nginx terminates TLS and proxies plain HTTP to Node.js, your Node.js app needs to know whether the original request was HTTP or HTTPS. Nginx sets X-forwarded proto, HTTPS for HTTPS requests. Your app should check this header for HTTPS sensitive logic. In express.js, enable trust proxy to process forwarded headers correctly, appset, trust proxy, 1. With this setting, REQ secure will be true for HTTPS requests, even though the request arrived at Node.js as plain HTTP, and REQ protocol will be HTTPS. Verifying trust proxy is working. Add a test endpoint, apt-get/debug proto, REQ, res, equals res.json, protocol, REQ protocol, secure, REQ secure, host, REQ hostname, hit https://mapp.com/debug-proto, protocol should be HTTPS and secure should be true. If they're HTTP and false, trust proxy isn't configured or Nginx isn't setting the header. Cookie security flags. In an HTTPS application, session cookies should have the secure flag, only sent over HTTPS, and HTTP only, not accessible to JavaScript. In Express, set these in your session middleware configuration: cookie, secure, true, HTTP only, true. Testing cookie security. Curl the https://mapp.com/login and look at set cookie headers in the response. You should see secure and HTTP only in the cookie attributes. HTTPS only redirect in application. Some applications do the redirect at the application layer. This is redundant if Nginx handles it, but can be a useful defense in depth. Ensure the application redirect uses REQ secure or X-forwarded proto, not REQ protocol, to avoid always redirect loops. HTTP security headers protect users even after HTTPS is established. Verify they're present and configured correctly. Check for strict transport security. Curl https://mapp.com, grep strict transport security. Expected output, strict transport security, max age equals 315360000, include subdomains. If missing, add it to your Nginx configuration, @_header strict transport security max age equals 315360000, include subdomains always. Other security headers to check: X content type options, nosnif prevents browsers from MIME sniffing responses. Curl check, curl https://mapp.com, grep X content type options. X-frame options, semi-origin, or deny, prevents your site from being embedded in an iframe on other sites, clickjacking protection. Check, curl https://mapp.com, grep X-frame options. XXSS protection, 1, mode equals block, for older browsers, enables the browser's built-in XSS filter. Content security policy, defines which sources of content the browser should allow, scripts, styles, images. The most powerful but also most complex security header. Referrer policy, controls how much referrer information is sent with requests. Adding security headers in Nginx, in the HTTPS server block @_header X content type options nosnif always, @_header X frame options semi-origin always, @_header referrer policy strict origin when cross-origin always, online header checker, securityheaders.com analyzes all headers on your domain and grades them. Useful to see which headers are missing. Don't wait until 30 days before expiry to discover that automated renewal is broken. Test it proactively right after initial setup. Step 1. Verify the certbot timer exists and is active. System status snap.certbot.renew.timer or certbot.timer. It should show active, waiting. If it's inactive, enable it. Sudo systeml enable now snap.certbot.renew.timer. Step 2. Run a dry run renewal. Sudo certbot renew dry run. This simulates the complete renewal process. Congratulations, all renewals succeeded or no renewals were attempted means the renewal mechanism works. An error here means renewal will fail when it's actually needed. Step 3. Verify the pre and post hooks. Certbot's Nginx plugin installs a deploy hook to reload Nginx after renewal. Verify it exists. ls/etc/let's encrypt /renewal hooks /deploy / you should see a script like Nginx or certbot Nginx. This hook runs sudo system to reload Nginx after each successful renewal, so Nginx picks up the new certificate. Step 4. Check renewal configuration. cat/etc/let's encrypt /renewal /myapp.com.conf. Verify authenticator equals Nginx, not standalone, and that the domains listed match your current setup. Step 5. Monitor expiry dates externally. Set up an external monitoring service that checks your certificate's expiry date and alerts you 14+ days before expiry. Services like Uptime Robot, Checkly, or StatusCake can do this. If automated renewal fails, you have 14 days to diagnose and fix it before the site goes down. A reference of the most common HTTPS issues you'll encounter and their fixes. Issue: mixed content warnings. The browser shows a padlock with a warning. Some resources, images, scripts, CSS, are loaded over HTTP even though the page is HTTPS. The browser warns because HTTP resources can be intercepted. Fix: find all HTTP resource URLs in your application and change them to HTTPS. Set content security policy: upgrade insecure requests in your headers to automatically upgrade HTTP resources. Issue: HTTPS works from browser but curl fails with certificate verify failed. Fix: ensure you're using fullchain.pem not cert.pem. Run certbot Nginx to reinstall if needed. Issue: site redirects in a loop, HTTP HTTPS HTTP HTTPS. Fix: your application is doing a redirect based on REQ protocol, which shows HTTP even for HTTPS requests, because Nginx proxies as HTTP. Enable Trust Proxy, AppSet, Trust Proxy, 1. The app should then see X forwarded proto, HTTPS and not redirect. Issue: HTTPS works for the root domain but not for subdomains. Fix: your certificate might only cover the root domain. Check the SANs in the certificate. If www.myapp.com isn't listed, reissue with www.myapp.com included. Issue: err_SSL_version_r_cipher_mismatch. Fix: your Nginx TLS configuration might have outdated settings. Ensure you're using certbot's options SSL Nginx.conf. Update it: certbot renew force renewal updates the conf file. Issue: certificate valid but err_cert_common_name_invalid. Fix: the certificate's SANs don't include the domain you're visiting. Reissue the certificate with all needed domains. Run through this checklist after any HTTPS configuration change. It takes less than 10 minutes. Step 1. Basic HTTPS connectivity. curl https://myapp.com http/2200 with no certificate errors. Step 2. HTTP redirect. curl http://myapp.com 301 with location, https://myapp.com. Step 3. Certificate verification. openssl_client connect myapp.com 443 server name myapp.com 2/dev/null openssl x509 dates check expiry date is far in the future. Step 4. Domain coverage. Check SANs include all your domains. openssl_client connect myapp.com 443 server name myapp.com 2/dev/null openssl x509 text grep DNS. Step 5. Certificate chain. curl https://myapp.com 2 and 1 grep SSL certificate verify OK. Step 6. HSTS header. curl https://myapp.com grep strict transport security max age equals 3153600. Step 7. Application layer. Test the debug endpoint or check that REQ secure is true and express. Step 8. SSL labs grade. Run sslabs.com/SSL test should be A or better. Step 9. Renewal dry run. Sudo certbot renew dry run succeeds without errors. Step 10. A timer active. System status snap.certbot.renew.timer active, waiting. All 10 steps passing equals your HTTPS setup is solid. A scenario testing understanding of the complete HTTPS stack. Your Node.js Express app is behind Jinx with HTTPS configured. The SSL certificate is valid, you can see the padlock in Chrome. But when users log in, they get logged out immediately. You check the Express session cookie and see it has the secure flag set. What's most likely causing the session issue? Option A, the SSL certificate is misconfigured, sessions need a wildcard certificate. Wildcard certificates have nothing to do with session cookies. Option B, Jinx is stripping the cookie headers. Jinx's proxy_pass configuration typically passes all headers through. Jinx wouldn't strip valid cookies. Option C, Express is not configured to trust the proxy, so REQ secure is false even over HTTPS. With secure flag on the cookie and REQ secure equals false, Express refuses to send the cookie because it thinks the connection isn't secure. Users get the login cookie on the HTTPS response, but it's rejected on the next request because Express's session middleware thinks the connection is plain HTTP. Fix, add appset, trust proxy, 1, to your Express app. This is the correct diagnosis. Option D, the session store is clearing sessions, nothing to do with HTTPS. The issue would happen on all connections if it were a session store problem, not specifically related to HTTPS. The answer is C. When appset, trust proxy, 1, is missing, REQ secure is false even for HTTPS connections, because Jinx proxies is HTTP. With the cookie's secure flag requiring a secure connection, Express won't set or send the cookie. The fix is 2 lines, appset, trust proxy, 1, in Express, and confirming proxy_set_header x forwarded proto is in your Jinx config. These two work together and Jinx sets the header, Express reads it.